Okay, good afternoon, pilot teachers, and good afternoon, students. Thank you. Sit down. Okay, we on the topic of gradient, and with the work on gradient, we are trying to see if we can calculate gradient, and from our calculations, what we are supposed to be able to pick up is the steepness of the slope in which we are asked to calculate the gradient of. What I will do today is basically go through the steps of calculation of gradient again, and then we are going to get a couple of students to come up to the front to show the working out on the 3 activities that you were supposed to have completed for your homework, and as well as the students would come out and show their working out, you will also explain to the class on how you got your answers for those 3 different activities. Okay, looking at what we have already covered on gradient, the steps now for the calculation of gradients. First of all, you are asked, or you may be asked, to find the gradient between 2 points. And if you are asked to find the gradient between 2 points, then it will have to be those 2 points that you will make reference to when you are doing your calculation of gradient. Find what we call the vertical difference first. To find the vertical difference, you need to be able to interpret the contours. Find the highest point along which is actually within that area that you are asked to find or calculate the gradient of. And you do the same for the lowest point. You find the lowest point within that area of which you've been asked to find the gradient of. Once you have found the highest point and the lowest point, then you subtract the lowest point from the highest point to get the vertical difference. The vertical difference then, that is the difference in height, is usually given in meters because your contours will already be in meters. So you get the difference, and the difference that you get will be the vertical difference. Step number 2, calculate the distance between the 2 points that you have been asked to find the gradient of. You need to check the scale of the map. You do your measurements from the 2 points, or along the 2 points, point A to B, for example. Then you go to the scale of that map. Using the scale of that map, you convert your answer so that your distance should be given in the same unit of measurement as that of the vertical difference. And the unit of measurement that you have been asked to use would be that of meters. Okay, so you find your horizontal distance. Find the distance by measuring between the 2 points that you've been asked to calculate the distance of. Then you use the scale of the map and you convert your answer to meters. So then you have the same units of measurements to calculate the gradient. Once you have found the vertical difference, you put that now over the horizontal distance. Now with that information, you simplify. After you're simplifying, if you cannot further simplify and you still do not have a number 1 over another number, then you need to divide the numerator into itself to give 1 and the numerator into the denominator to give whatever number that you would get from that division. At the end, it is important that we give our gradient in a ratio form of 1:something, or in fraction form of 1 over something. And that 1 that we have found will tell us the vertical difference, that is, or the rise. And whatever number we get for the horizontal distance then is the run. So generally, after we have found our gradient, then what we would see from that information will be, for every so many meters that we go across, that will be shown on the numerator, that will be shown on the denominator. For every so many of that number we go across, we will go up by 1. And that 1 will be shown in the numerator. So the numerator will always represent the rise, and the denominator will always represent the run, or the horizontal distance. Okay, from that explanation now, we are going to go ahead with you showing the rest of us how you have calculated the gradient for the other 3 activities that were given for homework. We'll get 3 volunteers, and those 3 volunteers will work on, one of the students will work on B, and that is calculating the gradient from point A to point B. One student will do C, again gradient of A to B, and another student to do D, A to B. Note that the example, the first example for A, we have done already yesterday together in class. So therefore, we will look at B, C, and D. Any volunteers now for A? For B. Anyone would like to show us what you have or how you've calculated your answer for B? Thank you, okay. You can come up and use the side of the board. That's for B. We'll have C here and D out there. Sorry, this is B, C, and D. Okay, we have a volunteer for C. A volunteer for C? Bill can come up for C, and D, volunteer for D. Would you like to do D? Okay. Come and put your working out now on the board so that as soon as you finish the working out, we'll have the first person to do the explaining while the other 2 wait here. And then when it is your turn, you come up. Quickly. For the working out, we'll put the information on the board together. Meanwhile, the rest of you, you're going to check, see if your answers are similar to what will be put up on the board, if those answers on the board are correct. Bill? Would you like to put the answer for C up on the board? Since Bill was not in school yesterday, you were not in school too yesterday. Would you like to put the answer for B on the board or C? Okay, you put C on the board. Quickly, come. Okay, Catherine will start off with the explaining on her working out and also her answer on the board.
With my ruler, I measured it from the distance from A to B. I came up with 5.4 centimeters. I used the scale, which is 1:25,000 centimeters. I cross-multiplied and came up with 135,000 centimeters. I divided by 100 because 100 centimeters is equals to 1 meter. I came up with 1,350 meters. To get the vertical difference, I subtracted 180 from 80. 180 is the highest point, and 80 is the lowest, so I came up with 100. When I simplified it, I came up with 1/14, which means for every 14 meters traveled horizontally, there is a raise of 1 meter.
Okay, the rest of us, let's check our answers. The way she's explained this, she's done the explaining very well. So there's no need for me to further do to go over the explanation again. The answer is correct, definitely, 1/14, as given or as stated by Catherine. You do your corrections? Okay, we look at the second one, Francis.
First of all, with a ruler, I measured the distance. I got a vertical distance. And I got, to find a vertical difference, first of all, I measured the distance and I got 140 centimeter. Oh, sorry. I got 140. To get the vertical difference, 140, I subtracted it with 20 meters and got 120 meters. And sorry. I measured a ruler. I got my ruler and measured the distance between A and B, and I got 5.3 centimeters. And I multiplied with 25,000 centimeters. And I got 132,500 centimeters, and I converted to meters. I divided by 100, and I got 24 meters divided by 262. And I further divided to get 11.42 meters. And then I rounded up to the nearest, and I got simplified. I simplified the 24 to 265. And I got 11.042 meters, and it is approximately 1/11 meters. So for every meters I go across, you will rise up to 1 meter.
Okay, thank you very much, Francis, for actually giving us the answer. The answer that Francis has up there is definitely correct. We'll double check and we'll go through what he's actually given for us. He's done everything here correct. We check. First of all, he found the vertical difference. And the vertical difference is simply the highest point and the lowest point. And he found the highest point is 140. The lowest point is 20. He subtracted and got a vertical difference of 120. And that 120 is in meters. Okay, he did the converting correctly. Found the distance between A to B 5.3 centimeters. Used the scale 1 is to 25,000. He multiplied 5.3 times 25,000, and he got 132,500 centimeters. So he converted that to meters by dividing by 100. And when he divided by 100, he got 1,325 meters. So he got the vertical difference, 120 over 1,325. He simplified that, and he got 24 over 265. Couldn't further simplify this, therefore he divided the numerator into itself, 24 into 24 to give 1, and then he divided 24 into 265 to give 11.042, etc. And he rounded that off to the nearest whole number, and he got 1 over 11, or 1:11, which means for every 11 meters you go across, there is a rise of 1 meter. Thank you, Francis. You've explained that to the class, and the class could follow with your working out on the board. Finally, the last activity for homework, that is D.
How I got my answer? The vertical difference, the highest point and the lowest point. So the highest point is 178 meters.
Come on this side, sorry. We'll start again from this side so it's easier.
How I got my answer? I measured the highest point and the lowest point. The highest point 178 meters and the lowest point 144 meters. I got the vertical difference, which is 134 meters. And the measurement I got on the ruler, which I measured from point A to B, 5.4 centimeters. I multiplied it by the scale, which is 25,000 centimeters. I got 135,000 centimeters. I divided by 100. So 100 centimeters make 1 meters. I got then I got 1,350 meters. And I just further simplified it over 134. I divided by 2 and I came up with 167 over 675. I further simplified it and I got 1 over 10. So for every 1 meter across, every time I go across, there's a raise of 1 meter in height, going up.
What's his name again? Frank. Okay, thank you, Frank. Again, Frank has explained this well enough for you to actually follow. Okay, anyone with any queries? The answer here, 1 in 10, is correct definitely for this particular example. That's example D. For every 10 meters you go across, there is a rise of 1 meter. So all our answers for the homework, as explained by the students on the board. And we can look at those answers again from the monitor. The first answer, as given, 1 in 14. That's exactly what has been explained by Catherine, no problem. I think the steps were clear enough, so you can double check, make your corrections. The second activity that we have actually, or that has been done by Francis here, you have the answer 1 in 11. Again, the working out similar to what has been actually put up here by Francis. And finally, the last example, we have 1 in 10, and the answer on the monitor is put up by Frank on the board. Any questions with regards to calculation of gradient? No questions? Okay, we have 4 more activities that you're going to work on now and see if we can come up with the answer before the bell goes for the end of the period. Okay, you have in front of you a worksheet that contains 4 contour patterns, and you are required to calculate or to find a gradient for each of the examples from the handout that is given. Okay. Now that we are familiar with the calculation of gradient, this should not take you long. Maybe, let's say 4 minutes for you to come up with an answer for each one of those 4 different activities. 4 minutes, plenty of time? Okay, good. For contour patterns, check the monitor to confirm the dots. The dots are the ones in the red color from the monitor or on the monitor. Can I just use your calculator? This one here is. You right with the calculation? Which scale did you use? Okay, so for each one here, they have their own scale, so you use the scale for each one. So that means vertical difference, and then horizontal distance will be the scale. This one, vertical difference, horizontal scale, use that. What's the first one? Okay. Yeah, okay. We'll check that later. What is on here? One is 86. 86. And the last C. Still working. We said 4 minutes, and our 4 minutes is up. We'll need more time. Okay, maybe another 2 more minutes. We'll have to work a little bit quicker or faster. It's 4.4, the distance. Need to be got it done? Follow it. Got it done, follow them. Okay, 175, yeah, 1 in 26. Let me check the last one, 1 in 26. Okay, there will be some variation from what I will be showing on the monitor because of the way in which the calculations have been done. But for the rest of us, whatever answers that we get, if we did measure accurately, we would have come up with the same answer. But already I'm checking the answers with the students. A lot of students are getting, like, you got 1 in 80, this one is 83. Yeah, there's a little variation. So whatever the variation is will depend on how well we measure and all that. So your answers are not wrong if I put it up on the monitor then. Okay, we'll check on the answers for those 4 activities. Okay, as I was actually walking around, I've checked, and a couple of students, when we go through the answers that you see from the monitor, there might be some variation with the measuring especially. So if our measurements, especially measuring the distance from point A to B, and if someone has 4.3 and someone has 4.6 and someone has 4.7, you will find that it will make a big difference in the final answer that we get for our gradient. So we will check with the answer from the monitor, and then later on, I will actually collect your exercise books and I will check the answers that you have in your exercise book. So let's look at the answers from the monitor together, and we'll check to see, first of all, if our calculations are following what we are expected to follow, and if our answers are close to what is given from the answers on the monitor. Okay, looking at the vertical difference, first of all, for the first of the contour patterns from A to B, the difference will be, the highest point is 140 and the lowest point is 80. And the difference will be 140. Oh, sorry, not 140. The difference will be 60 meters. The highest point, 140 is the lowest point, 80 meters. The difference then will be 60 meters. The 60 meters is the vertical difference. The horizontal distance, this time measuring from point A to point B. Some of you may have 4.4, but for the information on the monitor now, we'll follow this 4.6. You multiply that by the scale. The scale is 1:100,000. So when we multiply by the scale, we make sure that we do the converting to meters. 4.6 times 100,000 divided by 100, because there are 100 meters in, 100 centimeters in 1 meter, and we end up with 4,600 meters as the horizontal distance. Okay, we have 60 over 4,600. We simplify 3 over 230. And we have 1 over 76.66, or 1:77, or 1 over 77 rounded off. So here we are saying for every 77 meters across, there is a rise of 1 meter. Okay, again, like I've said, you check, your answers might be closer to 77, but I will check your exercise book for the correction of this one. Okay, we move on to B. For B, vertical difference, 140 is the highest point, 120 is the lowest point. You double check. 140 highest point, 120 lowest point. Therefore, the difference is 20 meters. 20 meters is the vertical difference. Measure the distance from A to B, you will end up with about 7.2 centimeters. Use the scale, 1:25,000. Divide that by 100 to give you your answer in meters. So 1,800 is the horizontal distance. 20, which is the vertical difference, over 1,800, which is the horizontal distance. I simplify, I get 2 over 180, and then I get 1 over 90. Which is the gradient for B. Which means for every 90 meters I go across, there is a rise of 1 meter. Your answer is closer to 90 meters across, 1 meter up. Okay. As I've mentioned earlier on, I will collect your exercise books to check on the answers that you have got. We are going through the answers from what is given on the monitor. Okay, let's look at C. Vertical difference, 100 meters is the highest point. The lowest point here is 60 meters. The difference is 40 meters. Scale of that map, 1:50,000. Therefore, the distance when measured, 6.6 centimeters, multiplied by 50,000 divided by 100, and I've got 3,300 meters, which is the horizontal distance. 40 over 3,300 meters. Simplify that, I've got 2 over 165. And then I end up with 1 over 82.5, which is approximately 83. So therefore, my answer is 1 over 83, or 1:83. For every 83 meters I go across, there is a rise of 1 meter. That's for example C, or activity C. And finally, for the last one, that's D. The vertical difference is 70 meters. 70 meters is taken from 140, the highest point. The lowest point is about 70 meters. 6.7 is the distance. Multiply by 20,000, which is the scale, 1:20,000, divide by 100 to get my answer in meters. So I have 70 over 1,340 meters. Simplify it to 7 over 134, which is 1 over 19.14, approximately 1 over 19 or 1 in 19. So basically what we have done here is we have looked at how you can actually calculate gradient, and from the calculation of gradient, you're simply finding out the steepness of the slope. So how steep the slope is from point A to point B is the gradient. And that is how we calculate gradient. Any questions? Again, I did mention that if our calculation of distance is different in terms of our measurement, then our gradients will vary or differ. So we have to be very accurate with our measurements so that we come up with the same answer when we are calculating gradient. If there are no questions, let me give you your homework. On the handout, which contain the explanation on gradients, at the back of that worksheet, we have already done those 4 activities that are given. There will be another lot of activities given on a second handout or worksheet which I will distribute. And from those second lot of handout or worksheet which I will distribute will contain your homework on more to do with calculation of gradients. I'll give those to your class captain to distribute. But for the students who are watching, the 2 activities or exercises on the monitor will be what you will be doing for your homework on calculation of gradient. Okay, class, that has actually brought us also to the end of the lesson. If you can now stand up. Okay, to the pilot teachers, our keyword for today is vertical difference. It's lesson 14. Good afternoon and thank you, students.